Hello ChemComm. So far we've talked about covalent molecules that are separated within a fractional distillation tower. Today we're going to learn how to name them correctly. Let's get started. There are two different naming systems we're going to learn today. The first one is how to name a covalently bonded substance, and the second one is how to specifically name a type of hydrocarbon called an alkane. Let's start with the covalent compounds. This naming system is pretty straightforward if you understand how to use prefixes to tell how many of something you have. When you're naming a covalent compound, the first thing you're going to do is determine the first element that you have. If there are no subscripts, we're just going to name the element as it is because there's only one of them. But if there is a subscript, we're going to use a prefix that tells us how many of that element we have. So for instance, the prefix di will mean 2, tri will mean 3, tetra 4, all the way up to deca, which means we have 10. Then we'll look at the second element. The second element will have a prefix even if there's only one. This prefix will be everything from mono to deca. Notice on the first element, we don't use the prefix mono, ever. If it's an element by itself, we just list the element. But on the second element, if there's only one, we do use the prefix mono. The other thing we do with the second element is we change the ending to IDE. So oxygen would become oxide and phosphorus would become phosphide. So let's work through some examples here. We see in this first one we have nitrogen and there are two of them. So we would put the prefix di in front of nitrogen, dinitrogen. And then we have 5 oxygen. So we'd put the prefix penta in front of oxygen, and then on the second element, we change the ending to IDE. So this would be dinitrogen pentoxide. The prefixes tell us how many we have. Here is BF3. Boron is by itself. On the first element, we do not use the prefix mono, so it's just boron. And then there are 3 fluorines, so that would be trifluoride. Here is CO. This is a molecule you've heard before. There's only one carbon, no mono on the first element, so carbon. And then there is one second element, and we do use the prefix mono on the second element. So this is carbon monoxide, a deadly gas that we try to avoid. You might look at this and say, that's just water. Correct, but it is a covalent compound, and based on our naming system, we could call it dihydrogen monoxide. So if you want to sound cool in front of your friends, always refer to the water fountain as the dihydrogen monoxide fountain. But then you might want to explain that that's just water and it's not some crazy chemical that you just made up. SBr6, there's only one sulfur, so just sulfur. And then hexa is the prefix for 6, and therefore hexabromide. And then finally we have phosphorus pentachloride. Notice in this list, all the second elements have "ide" as the ending because that's how we name covalent compounds. There are a few special names that you should be aware of. First of all, H2O is water. You know that one. But there are others that wouldn't be referred to as their traditional name and would be referred to by their common name. CH4 is methane and NH3 is ammonia. So anytime you would see those molecules, instead of saying carbon tetrahydride, you could just say methane. And instead of saying nitrogen trihydride, you could just say ammonia. All right, now that we've named the covalent compounds, let's take a look at something called an alkane. An alkane is just a hydrocarbon that only has single bonds. There's a bunch of different ways to model alkanes. We can use a ball and stick model. So a ball and stick model is simply just going to use spheres and bonds to show the spacing between these things. A space-filling model is going to be very similar. It's just that you're not going to draw the sticks. You're just going to kind of mash all the atoms together to show that they're kind of overlapping. And then finally, we might draw it as its actual shape. So methane is actually a tetrahedron. And when we draw that, there's actually 2 hydrogen atoms coming forward. There's one going backward, and there's one going straight up. It's kind of a pyramid structure that looks like this. We don't get a whole lot into shape of covalent molecules. This is just giving you a little bit of background on what that looks like. So here's the structural. You can see that that's probably the simplest and easiest to draw. Then ball and stick has the spheres, and it shows the bonds and their angles a little more clearly. And then the space-filling model kind of removes the bonds and kind of mashes all the atoms together, showing how those electron clouds overlap. We also have a couple different ways to show the formula. A molecular formula is typically going to put the number of carbons first and then the number of hydrogens second if we're dealing with a hydrocarbon. So we have 1 carbon, 4 hydrogens, 2 carbons, 6 hydrogens, and so on. A condensed formula shows the carbons and hydrogens as they are arranged in the molecule. So if we look at examples on this on the next page, here's our molecular formula for ethane, C2H6. There's our structural formula that shows our structure. And then the condensed structural formula, it's going to write it in a way, really you have a CH3 here and a CH3 here, so it's going to write CH3, CH3, because then it tells you how it's arranged. Same thing down here. Notice how we have propane C3H8, which is exactly what this is, mapped out. But if we write it in the condensed structural formula, it's a CH3, then a CH2 in the middle, and then a CH3 at the end. So the condensed structural formula, it just helps us understand how those atoms, those carbons and hydrogens, are arranged. All right, so let's name some alkanes here. Alkanes are named based on the number of carbons. And we also use a prefix system, but it's a different prefix system that we use with covalent. So specifically, when you only have carbon and hydrogen, we're going to name using this prefix system. 1 is meth, 2 is eth, 3 is prop, 4 is bute, and you can see that these prefixes are less familiar to you. Just so you know, you will always have a prefix list for both covalent naming and alkanes on any quiz and test. When we name alkanes, all we do is we count the number of carbons, and then we get the appropriate prefix, and since they're alkanes, we put the suffix -ane on the end. So this molecule has 2 carbons. If we go back to our list, we see that 2 is the prefix eth. And at that point, all we would do is put -ane on the end because this is an alkane. So this is ethane. Here's one that has 9 carbons. The prefix for 9 is non, and so this is nonane. Another one that you're probably familiar with is propane. If you look at the list, prop is the prefix for 3, so this would be the formula for propane. Another thing that's important here is you can always figure out how many hydrogens you have by doubling the number of carbons and then adding 2. So for instance, if I asked you, you have a molecule with 5 carbons and it's an alkane, how many hydrogens you have, you double the number of carbons to 10, and then you'd add 2, which means the alkane with 5 carbons would be C5H12. Notice we've done that here too. Propane, if we double this to 6 and add 2, we get 8. Ethane, if we double 2 to 4 and add 2, we get 6. Nonane, if we double 9 to 18 and add 2, we get 20. So an alkane will always fit that pattern. The hydrogens will always be double the amount of carbons plus 2. That's all we wanted to get through today. Make sure you keep the naming systems for covalent substances and alkanes separate. Practice these on the activity today. Keep up the good work. We'll see you soon.